Hey everybody, this is Larry. This is me going Q4 of the weekly contest for 19. Find X sum of all K long subarrays 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. First things first, today I'm really off on my metagame. I mean, I think algorithmically I was able to solve everything in my head, but this one, for example, I just have a 5-minute penalty. And I have a 5-minute penalty even though honestly, I forgot until I was doing the Q1 video that this is a copy of the Q1 problem. And what I mean is that if I had submitted my wrong answer, which I just had an off by 1, if I submitted my wrong answer for Q1, it would have saved me a wrong answer and it would have saved me 5 minutes of penalty. Just a lot of silly things like that today. It's just, some days you're a little bit off. And today is one of them. But anyway, this one, as we go over Q1, is kind of a tricky problem, right? The first thing to notice is that the sliding portion of it, right? Because basically, maybe I'm trying to bring up paintbrush so I could draw that. Maybe I don't need to draw really, right? Maybe I can do this on ASCII art a little bit, right? But the idea here is just sliding window, right? And the sliding window is not easy, obviously, because otherwise a lot of people would have gotten it. But the sliding windows is just going by, just thinking about, okay, as we slide, what happens? That's what I want people to think about, right? So here, I mean, I know that for example 1, the X is actually, or the K is actually 6, but let's just pretend we're only sliding 4 things, right? So here, first of all, we can calculate the answer for the first K is equal to 4, right? And then now we slide, right? What does sliding mean? Sliding in this particular problem means that, okay, in this case, we added 3, right? And we subtract a 1. So these are kind of the events that we're trying to do. And what does it do to change the answer, right? Well, the answer before is that we have 2 2s, we have 2 1s, and maybe that contributes to the answer. And then now, after sorting, now we have 3 1s, or sorry, 1 3. We still have 2 2s, 1 3, and 1 1, right? Because one of the ones got out, right? So, and then you kind of, do it manually a few times, maybe even in your head if you find it easy. And then you get this idea that, okay, well, my first idea actually during the contest was that, okay, we have an update heap, then we're able to kind of, and you can probably do this, but it's really tricky, or at least for me, to kind of just like, because the thing with most heap or priority queue libraries is that there's no update function, right? You can add, you could remove, but there's no update, which is actually also a thing that's critical in Dijkstra's algorithm, right? But that aside, so then I thought, okay, well, we don't have a library. And I also want to comment that at this point, that I think, the top people, at least the smarter top people, like the well-known, very good top people, I wouldn't be surprised if they have a heap library that has an update function that they could plug into this problem and get it like very quickly, right? I do not have this, unfortunately. So I was trying to figure out how to do it, right? And then my thought is that, okay, well, I can turn this into a bookkeeping problem by having a sorted list. I don't quite know how to do this in other languages as a result of that, but it's just maintaining the thing, right? And it's bookkeeping. What are we trying to keep? Well, we're trying to keep the biggest X distinct element. So then now it just becomes, okay, well, let's say you have this, and then now you have, let's say a barrier, right? And then everything is after that. And then now after you added 3, subtracted 1, you have another barrier. And then you want to keep track of what's inside. And that's really the thing you're trying to keep track of. So this total, for example, for this number is that we have 2 2s and 2 1s. So that sums up to 6. And then now we added 3, we subtracted 1. And then now we have a 4 plus 3. So that total is equal to 7. But, going from here to here, only a few things change, right? And in fact, we can actually, I know that I said this in one operation, but you can actually do this in 2 operations, right? It's just that we don't care about the one in between, which is added 3. So then once we added 3, we have already looked something like this. Actually, actually, well, it's still 2 1s, right? So we added 3, so total is still 6, right? We can do some math to look at where we added the 3, and the 3 is still at the very end, so it doesn't get in there. And now when we subtract the 1, then 2 things happen, right? One is that, well, the 1s went outside the barrier, and then the other is that something came in the barrier, right? So that's pretty much it. There are a number of different ways you can kind of do these steps one by one, but that's really the general way that I would think about it. And we'll go over the code as to how I did it exactly. And I think this is where, if you have a good abstraction in your head, it leads to good abstraction in the code. Though I made a few silly mistakes, and we watched the live portion of it, you can see it. But here, well, first of all, okay, let's start from the beginning. In the beginning, I keep track of with a sorted list, and the sorted list allows me to keep track of the top X frequency, right? And here, this is just a frequency table, right? It gives me the frequency of all the numbers, and we only go up to the K in the beginning because we want to do the first initial chunk before we start sliding. That's how I always do it anyway. And then here for X and this is just so that it's a little bit of a hack, but it just makes sure that we will create entries in the sorted list for things that don't appear in the beginning. So that's basically it. It looks very awkward for sure. And then M is just the number of unique things so that we can keep track of the last X elements by using M minus X, right? And then now here we add it to the sorted list, and keeping in mind that we sometimes may add zeros to the sorted list. And here we just get the total of the last X elements, right? The first window, this is the total for the last X elements, the ones we care about, right? And then now, after that, ignoring the middle function for a second, let's look at this part, right? It's what I said, right? So for every item, we add num sub I to it, and then we subtract I minus K from it, a very standard sliding window thing, and then we have the total. Of course, we have to actually write out this function, which is, pretty tricky, but we could do it. I believe in us. Especially me, because I always submitted it. Yeah. Anyway, so here, what I try to do is that I always remove. And because I have to do an update anyway, so I always remove. If I knew I was removing it, I look for where it is on the index first, and this will, it doesn't matter. Bisect left is good because this exact entry should be in sorted list, and if index is if this is in the top X, then we have to remove it. Because we know that we're moving it, so we would have to remove it from the total. And then we also want to, if we have enough elements, we want to add back in, right? The extra element. That is, for example, if you have someone like this, because we actually do it in 2 different steps, even for one of the steps. So in adding a 3, what we actually, well, maybe okay, let's say we have this thing, right? And then we add another 3. Right here, instead of going straight to just like increment, which it's a little bit tricky, what I actually end up doing is I subtract this one, or I remove the 1 3, so that now it looks like this. And when it looks like this, then we subtract one of the 3, right? 1 times 3 from the total, and then we add 1 times 1 back into the total, because now it went from this index to inside the critical barrier. And then now we add back in the extra and then now we add in the 2 3s, which is how I did. I guess technically 2 3s is in the beginning. And then now once we add this back in, we see that this is in the top X. So we put it back in the total, and we also push this thing out, and that's what we do here. So yeah, so basically if this is in the top X, then we have to subtract it because now it is no longer, and then we add back in the extra element that gets pushed to the front, to the top X. This is the new top X, and it's A times B because one of them is frequency, the other is value, right? And then now we remove it. And then now I say add 1 because we added the delta so that we make it easier to do +1 and -1. But yeah, and then we just find the index again. And again, if this is in the top X, we add it to the value. And if we have enough elements, then we remove the element that was previously on the cusp of the top X that just got pushed back. And yeah, and this is kind of the way that we are able to do it for both cases. And I think in theory, you can also have abstract this into its own function, but I guess for this problem, it wasn't necessary. So what is the complexity here, right? Well, this kicking off thing is going to be, this is linear time, this is log n time each, so this is n log n, right? For the sorted list. For each one, we do a calculation, and each calculation, a calculation loop. We do one binary search, one removal, one add, and another binary search. So 4 binary searches-ish log n operations in total. Everything else is all of 1-ish, I want to say. I mean, I think technically this is maybe log n, but either way, just more log n operations. And as a result, this is log n. And as a result of this is n log n, right? This is O of n, and this is n log n each. So we have n log n. And that's really pretty much it. Make it a little bit smaller so you see everything. And that's pretty much it. As I would call this a bookkeeping problem. You just try to keep track of where everything is and make sure that everything is in a precise way. But that's all I have for this one. Let me know what you think. I think the idea is not that hard for this one, but the implementation is definitely tricky. And that's where I think a lot of practice kind of comes in handy. And having this abstraction is not something that you don't get without enough practice on similar problems, I think. Or maybe just and enough practice could be like 1 or 2 problems. I'm just saying for me, it probably takes a little bit. And I still took a long time on this one, even though I knew how to do it. So anyway, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve a live in contest now. YOLO. Okay. So the answer is to not use Python. It wasn't that bad, but 112 people ahead of me. Okay, so this is Q1, right? So we have this weird sliding window E thing. Is it just bookkeeping? Let me open back up Q1 so we can solve this. I don't know how people got it so quickly, Q1. But so this we can do. This we can put in a heap. Just have to be. If you have a real heap, this is easy. Wait, is that true? No, it's fine, yeah. Okay, so then now, only one thing's changed. So then now it's whether... So you want to keep the things that are inside. But the decrementing part is the hard part. Right. Need a heap that goes inside. right? How do you? Maybe ChatGPT knows this. No, I'm not gonna cheat. But apparently there's a thing called heap dict. Is that a thing that's in Leetcode? Let's see. Nope. Okay, well. We could do a sorted dictionary or sorted list, maybe. Right? Maybe? I don't know. We have an hour left? Okay. Maybe we should be able to do this. Nope, we want just the first k elements so that we kind of pre-warm this list, and then f will contain whatever. So then here we want to say yeah, okay, for kiwi in f dot items, so dot add v1, v k is fine. We just need the back k half, right? Up. Also, I keep on doing this. How did this? Huh? Oh. This is kind of. I mean, this is actually bad code. It's just that this gets whatever. Okay, fine. That's actually pretty bad. I was. Okay, this is my input. Okay, whatever. Alright, right, and then now sum, the current total, is equal to the last k, right? Negative k, right, and then answer.append total. Just run it real quick. Type error, what? Oh, what am I doing? That doesn't even make sense. Total is equal to this. Sum of. Oh, and this is big K. Larry is being dumb today. Right. So do we get at least the first item right? Hopefully. 13 and 11 is really wrong. Why? Just do that. What is K? Am I confusing problems? We don't need to. It's X, Larry, X. You are confusing things. Oh, jeez. Okay, so this is 6 and 11. That is right to kick it off. Okay, and then now we start with K. We go all the way to N. This time it's N because we add the item, right? we add the item of num sub I. We add this item, and that means that this changed, right? So yeah. Yeah, okay. Maybe something like this. What is this syntax? Okay. So now we have some x and we have some delta, right? So then now we get f sub okay, so we have a pair of f sub x and x. That's the number we care about. That's in the SL. Right. And now if index is greater than equal to n minus k, then total we subtract f sub x times x, right? Yeah, okay. And then now f x increment by delta, right? So then now we add back in, and then if index is greater than n, okay, total we add in after. Something like this. Bisect left takes 2 arguments. Six, seven, seven. Again, negative numbers. Okay, that's just wrong. Right. Okay, so this is fine if it's removed, if it is added. But then now, okay, if this is the case, then we actually have to add in the new number, right? So if this is the case, we have to remove the number that is at exactly n minus, it could be n minus k minus 1. I think that's the other thing that I'm just like being lazy about. Okay, if k is 0, does this make sense? If k is 1, then index has to be n minus 1, right? So I think this is fine, maybe. Well, we'll see, I guess. Anyway, so if this is the case, then you have to take this number. I don't know, whatever. Oops. I think it's fine. I don't even know if this is right. Okay, if this is here, then we have to subtract this back out. Oh, I have to remove something. I think if this is the case, then okay, we do this, but then now we remove, so that is wrong. We move f of x, x, and then we add the delta, and then we add this, and if this is bigger, then we add it, but we also subtract the previous one before we add. Well, now we already added it. Well, we have to remove this either way, so that we increment and then do it. But yeah, this is probably off by 1, but I think we're closer. Hit me closer. 462. We just binary search for it, didn't we? Okay, let's print SL real quick. This is the list we care about. I mean, I'm confident we'll get it. We have 15 minutes. It just takes a while. Okay, so we want to change the 2 to a 2 to a 3. Now we have 3 2s. Is that right? We have 6, so we have D6, and then, okay, so now we have 3 2s. Okay, and then okay, we took away. Okay, so we subtracted and we added back on. Okay, and then we take away the 1. Okay, is the sorted list correct at least? 1 has 2, and then now 1 is 1. Right? So that's true. So we have 6. 2 2 2. Okay, so we have 6 from here, and then we added a 2, so this is 8, which is true. We remove the 1. But removing the 1 going to 5 is not right, because we have to add something back in, which is this part, I think. Back to 1, that's fine. And back to 1. So we haven't removed it yet, that's why. So then this is the one afterwards. Right? Okay, so then now it is 6 and 10. Okay. Okay, so then what? But then this is 9 because why? I'm just doing off by ones. I think we're mostly good, honestly. Okay, so we're moving back 4-1. Why? Or 1-4. Index. Did I do this right? Oh, I didn't check again. I meant to do that, but okay, so we add the 4. Is right. Am I just off by 1 here? Maybe I'm just off by 1 here. But Is the 0, 7? 7 is from the second case. Let's at least take a look at the output, the first case. Okay, the output for the first case is wrong. Why is this 12? So, okay, so adding this, removing this. No, this should not be right because, oh, I know that. Is this also like -1? Am I just doing it wrong? Okay, I mean, this is not right. But let's double check the math. 10, right? So then now, this is the sorted list. We care about this. We now 2, 3, 4, 5, 6. So then now we add a 3. So then we remove 4, add a 3. And then subtract 1 we don't really care about, that's fine. I wonder if that factors in, because is there a -1 thing? Oh, it's the sum of the array, which is fine. Okay. Alright, let's try the other one. I don't know why it's giving me an error. 0, 7 not in the list. Oh, of course, because it doesn't get added unless, yeah, okay. So then now here we actually want okay, yeah, we want something like for x in nums, f of x, something like this, something silly, just to make sure that we set everything. Okay, well, 11 is not going to be the right answer probably, but alright, well, this is why we don't submit yet. Okay, so we start here. We where we at? We only have 2 numbers, right? So that's actually easy to do, well, or easy to look at. We start 1, 3, 1, 8. Okay, we add a 7. We move to 3. Add a 7, we move to 3. And this debugging is impossible to read, but that's fine. Is it, Larry? Is it fine? Okay, so this is 11. Add the 7. Okay, we add. This should be. Ooh, is this right? Maybe I am off by 1 here. Well, it's not confident. I think I'm off by 1 somewhere, but because this is not adding the 7. Why? This is after adding x, right? So then now should do something here, right? So okay, so then now we have oops. Okay, so 7 delta 1, we have 2 n minus k. N minus k is wrong. What is the right one then? So it gives me 2 in the, oh, I see it. It's not the, no, this is right. But it's not n minus k though. It is the number of unique numbers. So it's not n minus k, it's m, where m is the length of the unique numbers, and that's why I keep on getting confused. Maybe this isn't even right. I mean, well, this is definitely not right, but I have to figure out how not right it is. Okay, well, maybe this is fine. Now we're just like YOLO trying things. Okay, let's focus a little bit. Okay, so we have M is equal, oh, no, this is fine. Yeah, I think this is fine. M is the length of, actually M can even just be, no, this is fine. Yeah. Alright. But now Q1 as well. Okay, so here we still have 45 minutes. We're doing okay on time. Could we be better? Yes, but I think we're okay. Actually, this is right, but this is really wrong. Why are you wrong for Q? For example, 1. 3 -2 is definitely wrong. We should not have -2. K, it's not K, it's X, right? Why do I still have K in random places? How did this get the first one right? It's just very lucky, or maybe in my case not lucky. I'm confusing variables. I hate single letter variables. This is why you should not have single letter variables. Okay, so this is now right, but am I actually right? Am I just a little bit lucky? That's the thing with all these things, right? I have to double check. So 0, this is 2. We want the last 2, right? So it's starting from the 2 index, is that right? M minus X, 2 index, this is right. Here, for the 7, we want the 2 index because the 2, I think that's right. So, okay. But are we minusing the right numbers? Would this make it wrong? I just want to, like, if this makes it wrong, it's actually a good sign because that's basically, it shows that we do something. Okay, I mean, I am going to YOLO a little bit. Probably maybe I could check a little bit more, but I think maybe it's worth the 5 minutes for me to get an example that is wrong so I could debug it like this versus trying to come up with cases and it just end up getting wrong anyway. Okay, 822. So do and then do. X is 2. It's 8 because, okay. Now I have to kind of put it back in. Alright, let's see. Okay. So we have, so the answer should be 4 because we have only one number. Right? Oh, no, but this should be 4, right? So 8 delta, we only care about the last. Oh, we do, I see. I don't remove this because it's, even though it's a 0. But I should though, right? Let's see. So we have, yeah, this debugging gets a little bit confusing. Okay, I mean, I know why, or I have an idea why this is wrong, but, okay, so if this is the case, we have 10, that's fine. So we add in an X. We don't delete anything because this was already in it. So then now, total is 16 is actually wrong, right? Because we have 10, we add in a 2, so 16 is absolutely wrong. So actually this -8 part is right, but I'm missing, maybe this is off by 1 somewhere. Something like this. No, that, well, I think I fixed this one, but not this one. So maybe something like this. My answer is still 10.8, it should be 10.4, okay. We still have 16. So, okay, 0 is the thing, right? Okay, so K is 0, so we always keep track of this. All right, let's put these back in. Also, this is just wrong. I think we had it right. Maybe the -1 is wrong, but maybe the no, I don't know. Okay. So we have 1.8. We were moving 2.2. How do we have 16? We're moving 4. Okay, so we have this. Adding back an 8 is really wrong. So okay, so we have this. We wanted to add 1 here, so we removed 1, 2. Does this go overboard? This goes into -1, that's why. Right, I mean, I think I know, yeah. So then now it's removing the first element, which is why. So this has to be, I guess this just, yeah, if, I think this has to be the thing. I think we're just kind of a little bit silly on the removing and adding. Or it's off by 1 because we go out of bounds. And then instead of throwing an error, and I think this is the edge cases that every number matters for this one for whatever reason. Alright, YOLO. If that's the only wrong answer, then I'm happy. I mean, if it times out, then I'm also sad, but alright, 97. I mean, I was pretty slow on this one. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, its explanation, everything in between. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.